Well, Joy, let's take a look at the tab and slot command. We'll look at using it for 2 perpendicular sheet metal parts, 2 inline parts, and we'll use a workaround to use it with a frame. Okay, so starting off, we're in an assembly here and we've 2 sheet metal parts. So the tab and slot is kind of designed for sheet metal parts, and these 2 parts are mated against each other. They're just butted up against each other. There's no interference between them. So I'm going to go to Features, choose Tab and Slot, and we can go here. We have Select Tab Edge. So as I hover over the parts, different edges get highlighted, and I just want to select an edge where the 2 parts are intersecting. So here, for example, and we see the orange line previewing where the tab edge would be if I select it, and we have an orange dot at the end of the line. That's the tab edge start, or the origin of that line, and that goes closest to the end of the edge where my cursor is. So if I move the cursor down here, it appears at the bottom of the part, and that's actually where I want it. So I'm going to click while it's there, and we move on to the next step, which is Select Slot Face. So we're going to make the tabs in the blue part, and we're going to make the slots to accommodate them in this chrome faced part. So I click on the chrome part, and we have these parameters here. So first of all, I'm just going to hide our chrome faced part, and we can see a preview of what our tabs are going to look like, and we can adjust them here. So our number of tabs we could change to 3, and the tab length we could change to 10. Our tab spacing is ghosted out at the moment. We'll look at that later. And then we have our start offset. That is defined by the tab edge we defined just a while ago. So we defined this line here as our tab edge, and we said the start of it was down here. So our start offset is 10 millimeters, which means 10 millimeters from the start of our tab edge to the first tab. That's 10 millimeters. And we can adjust that here. Our tab moves up. And similarly, we have our end offset at the other side of our tab edge. So we could change that to 15 millimeters and the tab moves down. So that's all fine. And you might have noticed as we adjusted these, our tab spacing gets squeezed in together or stretched apart. So that's why that was ghosted out. In a fit pattern, our tab spacing gets sacrificed to satisfy all of these other parameters. If that doesn't work for you, you could use a fill pattern, and now the number of tabs isn't available to select. That's ghosted out, and now we can select the tab length, spacing, start offset and end offset. So if I change that tab spacing to 20 millimeters, press tab, we're only able to make 2 tabs now to satisfy all those criteria. I kind of like the fit for this one, so I'm going to stick with the fit and change our tab length to 20, change the number of tabs to 2, and here we are. Okay, and looking next now, we have the slot gap type, and for that I'm going to turn on our chrome plate, and I'm going to change our slot length gap to 0.5 millimeters. That is, instead of cutting out a slot the exact same size as our tab, that is kind of creating an offset. So it offsets each face of our slot a 0.5 millimeter from the closest face of our tab. So it makes the slot 1 millimeter wider than our tab with a 0.5 millimeter each side, and 1 millimeter longer than our tab with a 0.5 millimeter each end. If you wanted more control, you could choose multiple slot gap values, and for that you could adjust independently the length and width of the gap for our slot. So we could make the length 5 millimeters extra each side and make the slot width a 0.5 millimeter. Okay, and we go to extent, and maybe we just go with a from to extent. The from is already defined, so the to is just this face. Click here, and there's our slot created, and we can go to finish. If we ever want to edit our slot, we go back to our assembly, we go to our Pathfinder, go to assembly driven part features, expand that out, click on the tab and slot, and choose edit. And now while we're here, I can show you there's a treatment here, and in here we're able to add something like we could add a round to our tab just to get rid of those sharp corners. We can edit any of these parameters we entered earlier, and for the slot we could enter rounds or chamfers on the slots as well, and we can change the values here. So maybe I'll change that to a 1 millimeter chamfer. Okay, click preview and finish. There's our modified feature, and it looks kind of nifty. We're going to save changes, and now there's our part, and that's ready to be brought into the draft environment and laser cut, and the same applies to our blue part. We can also use tab and slot features for parts that are buttered up against each other end to end. So let's take a look at that. I'm going to go to Home, Insert Component, drag in another part, and we'll just mate that in place. That's it, fully constrained. Going to go up here to Features, Tab and Slot, and to select the tab edge. Solid Edge seems to want to pick up on this chrome part. I actually want the golden one, so I'm going to use Quick Pick to select that. And our origin for our line was here. And now we're on to select slot face. So our slot face is here. And now we have the parameters. So the parameters have the exact same meaning as if you were using two parts perpendicular to each other, but it can be a little bit confusing when you flip it over. So again, the tab length is just the length of the tab along here. So if I change that to 15 and press tab, you can see them getting shorter. The start offset is from our start point here down. So you can see it adjusting there. And then our end offset is from the end of our tab edge up. So if I change that to 5, you can see it moving down there. Okay. And again, we can have a fit pattern or a fill pattern like before. All right, so we can use a slot gap again. If we go with a single slot gap value, it means all of the gaps around are consistent, in this case at 0.4 millimeters, or we can control it. So if we're controlling it, our slot length gap is related to our tab length. So that's what clearance we get relative to our tab length. In this case, we're given at 0.4. Our slot width gap is related to the width of our tab. So that's in this plane here. And in this case, both parts are flush with each other and they're the same thickness. So our slot width is just going to be the entire width of our part. It won't make any difference, but we'll do something later on to show that. Our slot depth gap controls how much deeper our slot is than our tab. Now we can move on to the extent step. Here we're defining how deep we want our tab to go into the other part. I'm going to type in 15 millimeters and press enter. You can see the clearances we've made between our tab and slot, and the slot has been cut right through our chrome part. So we can click finish here and cancel. If I click on this part, I'll maybe move it. Maybe we don't want them to be exactly in line anymore. So we can maybe move it up half the thickness of our parts, which is 1.5 millimeters. Press enter. And we're going to adjust offset values for our assembly relationships. Click OK. And let's take a look now at our part. Oh, it's no longer cut right through. We have this piece of material here. So the material that's kept there, and then we have a gap, and that gap between the material and our golden plate here is our slot width gap. Let's move on to the last example. We have a weldment with a frame and two tabs. It would be really nice to use the tab and slot command so we could laser cut our frame and tabs so they fit together nicely. But Solid Edge doesn't currently support that, so we'll have to get a little bit crafty. So what we're going to do is we're going to make a reference part, and in this case it's just going to be a standard sheet metal part. So we're going to say new ISO sheet metal part. We're going to create it in ordered, and we're just going to create a tab, and we'll give it a thickness of 5. We'll go up with that and click finish and cancel. Give it a little bit of color, and now we go back to our assembly, insert component, and because it's already open we can just drag it in. I'm just looking at it now, and that's not where we want it. I wanted this to be kind of inset into our box section. So let me see, if I click on this, we have a mate. Okay, so I'm going to change that mate by just clicking flip, and now it's flipped over and they're sharing the same front face. That's exactly what I want. And we can drag the part back up again. Yeah, we could do the same again. We could use a center plane, this face, this face, this face, and this face. Okay, so that brings them together. All right, so now our part is fully defined in the assembly. I'm going to click on this frame component and hide it. So now we have two sheet metal parts. So we can go to Features, Tab and Slot. For the tab edge, we can choose here. For the slot face, we can choose this. Number of tabs, I'm going to say 2. Press Tab. Tab length 20. I don't see anything happening. Start offset 10, end offset 10. That mightn't be working out, so maybe we could choose tab length 10. Press Tab. Yeah, now it's working out. It looks a little short, so we could change the offset to 5, the offset to 5, tab length 20. That works. Yeah, so I'm happy with that. We can go with a gap, an equal gap all the way around of 0.5 millimeter, and we can go to the extent. I'm going to choose a finite extent of 5 millimeters and click, and we can, oh, the treatment here. Actually, there's chamfers and radius from the last time we used that command. I don't actually want those. So I'm going to remove those, click preview, and we have our clearance and we have everything looking good. So I'm going to click finish and cancel. So now you'll notice we have the same part twice here, and the tabs have been added to both instances of that part. And if we click on the frame, we're in frame 4, so I'm going to expand that out and show that part that was hid earlier. So we still need to do some voodoo on our frame here, so I'm going to click on this part, right click on it and choose Save As, so we can save that frame element as a part. And now I'm going to hide the frame element, and we want to navigate to that part. So I'm going to go Open Document Folder, and I'm going to drag in that part from our folder. And the way that frame element was defined by default, it has the same position relative to the assembly origin. So we can just mate the two assembly origins. So I'm going to choose here, Match Coordinate Systems, choose the coordinate system of our part, show the coordinate system of our base reference plane and select it. They're brought together, and now our part is slotted right into place perfectly. So I'm going to hit save. So now let's do a little bit more with this part here, with our reference part. So I'm going to choose edit. The funny thing about this part is I kind of want everything but the part. So what I'm really interested in here are these cutouts. We want to kind of replicate those. So we can go to add body, and we can add part, we can add sheet metal. It doesn't really matter too much for this. So I'm going to say part, choose OK. All right, and we can go to sketch. I'm going to choose the face of our part as our sketch plane, and I'm going to choose project to sketch. We're going to turn off project internal face loop. So we're just going to capture the outline of our part. Click here, tick that box, and tick this tick mark, choose finish. Okay, so there's our sketch. And we can choose extrude. We could create from, select from sketch, choose the sketch we just created, right click to accept, and now we just need to choose the depth. I'm going to use the depth of our part here and choose finish and cancel. So now we kind of have two bodies taking up the same space, and what I want to do is subtract them. Click on our drop down menu here and choose subtract, and for starters Solid Edge is asking for the target bodies for the boolean, and I'm just going to choose the second body we created, which is just a plain rectangle without any cutouts. Right click to accept, and now it's asking for the tool, so I'm going to choose design body 1, what we started with, and I'm going to right click to accept that, right click to finish and choose cancel. Let's see what we have now. I'm just going to hide that sketch and hide design body 1. So I'm going to choose design body 2, toggle design construction, and there we go, there's our construction body. And that is showing, that's basically taking up the holes that were in our original body. We can save that, go back to our assembly here, and we have our part here. I'm going to right click on it in the Pathfinder and choose show hide component, turn everything else off, design body off, surfaces on. Okay, so now if we hide that part, we have that there. Okay, so that's where we want to cut out. We also want another cutout up here, and because these are identical parts, we can go to duplicate component. The component we want to duplicate is this one here, and I'm going to tick this box, and we're going to select from, they're going to be duplicated based on the occurrence of this part, and we're going to choose select all matching. So here's the other part, tick that box and choose finish. Okay, and cancel. All right, so now we have this part here, that's part of the pattern, and we have the part in here, which is okay. So we can click on this and choose Edit, and I'm just going to press Ctrl and Q, and we see this is all that's actually within that part. And if I press Ctrl and Q again, we're looking at items in the assembly. So we want to kind of borrow items in the assembly to use them to cut out our box section. I'm going to go up here, click on this drop down and choose Interpart Copy. And the parts we're going to copy are this little part in here. And we're going to choose Body there. Okay. I right click and right click to finish. And the other part is this one here. And we're going to choose Body. And I'm kind of hovering. I'm hoping I'm going to get another option here. Okay, we're not getting it. So I'm going to press Escape. And I'm going to close out of this part. Click on this part. And we're just going to expand it out. And we're going to go to Show Hide Component. Move over here. And we're going to hide. We're going to, for all types, we're going to choose Off. And for Design Body, we'll choose Off. And we're just going to turn on surfaces. Choose OK. And now we have those two little parts we want to cut out. Okay, so now we're going to go back to this. We're going to click on this part and choose Edit. And we're going to click on this drop down and choose Interpart Copy. We're going to copy these parts. We're going to select the body, click on it again, right click to accept, right click to finish, click cancel. Okay, so now I'm going to press Ctrl and Q. Now we're looking just at the part, no other parts. And we have these Interpart copies where we want our cutouts in our box section. So now it's getting interesting. We can just go to Subtract. This is our target body. Right click to accept. And now our tool is this and this. Right click to accept. Right click to finish. Choose cancel. And now we got our part with our cutouts. Okay, so now you can see through. We see we have our cutouts there. So I'm going to hit save on that. Close that part. And there is our part in our assembly. We can hide that and we can hide that part there. They're only reference parts. And if we wanted to, we could also choose occurrence properties to properly manage how that's treated in drawings and higher level assemblies. I'm going to create features, parallel plane from there to the midpoint here. I'm going to select this, choose that plane, go to PMI, section by plane. Tick this box, click finish, and now we can see there's our tab and there's our slots in our box section. That's it, Joy. I've organized videos into playlists you might like. Otherwise, talk to you in the next one.